And now we have the great privilege to proceed ahead with the next element in our program, which is going to be a talk by our NASA Administrator, James Bridenstine. So in manner of introduction, Jim Bridenstine's career in federal service began in 1998 as a pilot in the U.S. Navy, where he flew combat missions off the USS Abraham Lincoln aircraft carrier. He later moved from the E-2C Hawkeye to the F-18 Hornet and flew at the Naval Strike and Air Warfare Center, the parent command to Top Gun, and which is, of course, for many of us of a certain age, reminiscent of Maverick in the movie Top Gun. After transitioning from active duty to the U.S. Naval Reserve, Bridenstine was elected in 2012 to represent Oklahoma's 1st Congressional District in the U.S. House of Representatives, where he served on the Armed Services Committee and the Science, Space, and Technology Committee. Jim Bridenstine has served as the NASA Administrator since April 23, 2018. Under his leadership, NASA has developed the most powerful rocket ever built and launched its new human lunar exploration mission, the Artemis program, which will land the first woman and next man on the surface of the moon in preparation for future crewed missions to Mars and beyond. As administrator, he's managed commercial resupply of the International Space Station with a commercial crew program that has once again recently launched American astronauts on American rockets from American soil, something not done since the end of the shuttle program in 2011. Additionally, Bridenstine established the Commercial Lunar Payload Services Program that Ben spoke of earlier to partner with private enterprise in landing rovers on the lunar surface. These rovers will contain tools and science experiments in preparation for the arrival of American astronauts. Quite simply put, during his tenure, NASA has thrived. And with that, I am very proud to introduce Administrator James Bridenstine.
Well, thank you, and thank you for that introduction. Greg, can you hear me?
Yes, loud and clear.
Okay, all right, perfect. So I'll just, I'll kind of give a brief summary here, and then we'll open it up to questions. And I know there's a lot of amazing people that are part of this conference that might want to share their thoughts, which of course is always good as well. So I just like to say to start, when I became the NASA administrator, my highest priority was to maintain and even grow the strong bipartisan apolitical support that NASA has had historically. And the reason that's so important is because in order to achieve what we need to achieve, we've got to have increasing budgets. And that means we need Republicans and Democrats alike to be supportive of our programs. And I think for the most part, we have in fact achieved that. Right now, NASA has the highest budget it's ever had in nominal dollars. I would say in real dollars, Apollo was significantly higher, but we're not in an Apollo era right now. And in nominal dollars, we're the highest we've ever been. And in fact, right now, before the House and the Senate, we have a budget request of $25.2 billion, which is over $3 billion larger than our current enacted budget. So, and we're getting, again, broad bipartisan support. So I'll share with you kind of how this is, the reason this is happening and why this group focused on lunar exploration is so important. When I was in the House of Representatives, there was this argument about whether or not we go to the moon or we go to Mars. It's one or the other, but you can't be for both. And that was very divisive. And what ended up happening is Republicans were for the moon and Democrats were for Mars. I have no idea how these kind of things become partisan, but just by the very nature of partisan politics in Washington, D.C., that in fact did happen. We've also seen the split, Republicans are for human exploration and operations, and Democrats are for the Science Mission Directorate. Again, these are false narratives that we have to work every day to unwind, to make sure that we're looking at our agency as a whole, and how we're going to accomplish things together, unite our political leaders so that we all believe that what we're trying to achieve is important, and we can get those important budgets that are necessary to do lunar exploration. One of the things that I think is so impressive about what the team at NASA has accomplished is tying, and Thomas Zurbuchen gets a lot of credit for this, tying the Science Mission Directorate to the moon. It's always been that human exploration was about the moon, and the Science Mission Directorate was about everything else. And now we have, for the first time, the CLIPS program. That was my first initiative as the NASA administrator, the Commercial Lunar Payload Services Program. I saw a question from Clive Neal a little earlier. He was a big part of inspiring that initiative. So what does that mean? We're going to go to the moon commercially. We need to go fast. We don't want the government to purchase, own, and operate all the hardware. We don't want to create, thousands of requirements. We want to say, here's the payload. Here's the science instrument that we need to get to the surface of the moon. Who can deliver it for us? And so within the Science Mission Directorate, we now have a plan to get to the moon commercially with these small payloads. But what matters here is, by doing that, we now have the science community focused on the moon as much as the human exploration community. And what's so important is that the moon is in fact all about science, and it always has been all about science. And when we think about the Science Mission Directorate, we talk about astrophysics. One of the missions that I've been talking a lot about is the Dapper Mission, an orbiter of the moon that can not just see the first light in the universe, but can see back into the dark ages after the Big Bang and before the first light. And you can only see that with specific instruments on the far side of the moon. But earlier I heard of the talk about the communication architecture that we're building at the moon. If we have that communication architecture for what's happening on the surface of the moon, both with humans and with robots, all of a sudden we can do astrophysics around the moon, and astrophysics even from the far side of the moon on the surface of the moon, astrophysics that we could never do otherwise. And we can do it for a fraction of the price because the communication architecture is already there. We don't have to launch, all of the power that's necessary for, the communication capabilities and the large antennas, because we have a robust communication architecture already at the moon. So when we build the architecture for comms, we're doing it for human spaceflight to the surface of the moon and for robotic rovers, all of a sudden now it opens the aperture to what we can do with astrophysics, which is a big division within the Science Mission Directorate. But it also opens the door for heliophysics. The moon is basically an amazing repository for data and information from the early sun. The idea that the Earth has the very active atmosphere, very active hydrosphere. The charged particles that came from the sun because of the magnetosphere largely went around, and the particles that come into the Earth, they all get moved around. Well, the regolith on the surface of the moon is a repository of data and information of the early solar system because it doesn't have an active geology. It doesn't have an active atmosphere. And I know the audience I'm talking to, and there will be those who will say, well, there is a trace atmosphere on the moon. It's very, 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 I get it. We get it. There's ice and all these great things. But the point is this: by going to the moon with instruments and landers and rovers and humans, we can do astrophysics in a way we've never been able to do astrophysics before. We can do heliophysics in a way we've never been able to do heliophysics. We can do earth science. Remember, there's a big body of work from maybe a lot of people that are on this teleconference right now, a big body of work that would say that the moon was actually at one time a part of the Earth. So we can actually learn about our own planet by in fact going to and studying the Earth. So, and as far as planetary science goes, look, we're going to Mars. And if you want to learn how to live and work on another world, there is no better place to go than the moon. And why is that? Because it's always a 3-day journey home. And we learned from Apollo 13, things can go terribly wrong on the way to the moon and you can still make it home safely because it's always a 3-day journey home. But if something like that were to happen on the way to Mars, it would be over. So the moon is, it's about astrophysics. It's about planetary science. It's about the study of our own solar system and heliophysics and earth science. The moon is just an amazing place that we need to get to, and we need to study, and we need to use. That's the key word. We need to use it to get all of the science of our solar system and even the early universe before the first light in the universe. So I'm exceptionally excited about the moon, and it is not just about human exploration. And the question came up earlier, it can't just be about science. It has to be about all of the above. And so the strategy that we're using is we're saying, look, the moon is about human exploration, but it is also about all of the science that comes from the surface of the moon. And it's also about getting to Mars. So we create the Moon to Mars program. People are not going to be divided anymore on whether it's the moon or whether it's Mars. It is, in fact, both. We're not going to divide people on whether you're for human exploration or robotic exploration. It is, in fact, about both. And the moon is I think the best place that unites all of these different philosophies on what we need to be doing and how we need to be doing it. The moon is the uniting kind of driving force, and it's also achievable. So that's really what the Artemis program is all about. It's when I say achievable, Mars is achievable too, make no mistake, but we can achieve it in the short term. We can put points on the board. We can show the American public, and in fact, all of our international partners, that together we can accomplish these stunning achievements. We can inspire the world again, and we can drive more resources into more exploration than ever before. And so that's really what we're trying to achieve with the Moon to Mars initiative, with the Artemis program, with our budgets. Now, some people say, well, why are you pushing so hard to get humans to the moon by 2024? Why are you pushing so hard for that? Well, again, it goes back to budgets. And number one, we've tried to go to the moon over and over again in the past, and it never materializes, other than in 1969 through 1972. But even that program ended. But what are the challenges? So the challenges are, we've got to drive down costs. We've got to increase access. We have to make sure that we're creating sustainability, and that's humans and robots, rovers, landers, and all of the tools necessary for long duration stays on the surface of the moon. So, Greg, I'm thrilled to be here. There's a lot to talk about. I will tell you, we are achieving the bipartisan consensus. We just saw the House of Representatives. They're marking up a bill right now for NASA, the Commerce, Justice, Science Appropriations Bill. This is the opening salvo from the House of Representatives, which is controlled by Democrats. And they have $600 million in the bill for a human landing system. I think it's $620 million. Now, that's not everything that we asked for, but what it shows is that there's bipartisan support for this activity, and we can work with the Senate to help get more resources as is necessary to achieve the 2024 landing. But 2024 matters because, number one, it drives the budgets that we need to achieve these goals, and number two, the longer the programs go and the more expensive they become, the more likely they are to get canceled. And we've seen that over and over again. We need to put points on the board, and once we get there, we need to grow. We need to grow from there. Driving down costs, increasing access, reusability, all of these things need to be driven into the architecture. So I guess what I'll do now is I'll stop talking and I'll open it up to a few questions here. I think we have 15 more minutes.
Yeah, great. Well, Administrator Bridenstine, first of all, if you over the internet have heard the sound of 400 people collectively cheering, it's because of what you said. You know, the moon is the best place to unite, and boy, we could not agree more. You know, I've also gotten a few private messages from people asking if you can stay as administrator forever. So we'll have another conversation about that perhaps sometime. Thank you so much for your leadership and all of this for our community and for the nation as a whole.
Greg, it's interesting. I actually had a bill when I was in the House of Representatives. I had a bill that would make the NASA administrator a 10-year term, so that we could have constancy of purpose, just like the FBI. The FBI director has a 10-year term. Now that bill never went anywhere, but I made the effort. But I don't know. 10 years seems, now that I'm in the job, 10 years seems like a long time. So.
Sure. And I just got a comment from one of the next generation folks saying we are the Artemis generation.
That's right.
It's just like I'm part of the Apollo generation. I remember the Apollo 11 landing, like more than a few people on, they're going to have their missions that they remember. And you're bringing that to us, and that's just so exciting. And we're also very proud as CERVI and previously the NASA Lunar Science Institute to have given rise to some of these things, such as Dapper, through our funding of Jack Burns and his efforts. So we're very proud to be taking a part in this.
Let me give a shout out to Jack Burns, because he wasted no time in making sure he put that on my radar as early as possible. So it worked.
So anyway, let me ask more funding. Yeah, go ahead. Let me ask everyone. We would love it if you would ask the questions in person rather. And so please raise your hand, and we will be able to select you. And I'll mention that my deputy Christina Gibbs is online as well, and will help in selecting questions. Maybe I'll just start with one myself, and that's, what do you see as your biggest challenge right now, perhaps beyond the political sphere that you spoke of?
Yeah, so I think the biggest challenge is we think about the various ways to get to the moon, and then what do we do when we're there? And building consensus around ultimately the decisions that we make. So I'll just give you an example. We are now under contract with 3 separate providers for a human landing system to take us to the surface of the moon by 2024. And the budgets are not going to probably materialize for us to carry all 3 human landing systems, through the end. So the question is, will some of these companies continue to move forward commercially because there's going to be a future market for, whether it's resources or whatever it is on the surface of the moon or even below the surface of the moon? I guess the question is, if we do down select, which I think we probably will have to at some point, maybe sooner rather than later, depending on how these budgets materialize. Does the community then go pan, what the effort is we're trying to achieve? Do you know what I mean? Because they didn't get the contract they wanted, or they're going to go to their congressmen and senators and start making a stink of it? Because those are the kind of things that set us back. So, we've seen that a little bit already on CLIPS, where certain CLIPS providers were upset because other CLIPS providers. And I'm going to be very honest. They didn't like the outcome of something, and so they went and got their congressman involved. And that can be helpful for them, but it could be very damaging for the long-term prospects of what we're trying to achieve. And so the contractor on contractor violence sometimes does a lot more damage to the total effort than it does benefit to you as a contractor. So these are the things that we have to think about all the time, and try to make sure that we're maintaining the right balance. Trying to make sure that as we go forward with our acquisition programs, we're doing it with integrity, and not getting distracted by some of those very difficult issues that we have to deal with day in and day out. But I spend a lot of time creating the unity that we need to achieve these goals, and then it's really easy to just wreck shop in a heartbeat. So if there are folks on the line here that are involved in that, I just want you to have the perspective that I have. That's all.
Thank you. Thank you. We have a question from TJ Cooney, who has raised their hand. TJ, if you could turn your video on and your audio on, take it away.
Hey, Mr. Bridenstine, thank you so much for taking my question. So I know 2024 is our goal, which is a short 4 years away. I'm very much looking forward to that day when we get back on the surface of the moon. I know that for the first landing, the goals of it are going to be pretty much about getting to the moon, showing that we can do it, trying to prove out a lot of the science and get out of there, so to speak, not necessarily requiring to be on the surface for a very long time. But one of the advantages of having humans on the surface or working in space really is the amount of science we can do on the fly, be creative in short periods of time. As of right now, for that first mission, is there any particular science that NASA is prioritizing for those astronauts to do outside of demonstrate the capabilities of the landing system and all that, in terms of core samples or just anything? It would be fascinating to hear if there's any kind of science you guys are prioritizing for that first mission.
Yeah, in fact, we started a discussion on that just yesterday, and this is where NASA historically is divided between human exploration and the Science Mission Directorate, and we're going through the budget process right now for 2022, and we're asking, if the Science Mission Directorate wanted to have their say in what we're going to do on the surface of the moon when we get there, what does that look like and how much does it cost? And again, bringing together these historically kind of separate parts of NASA and saying, let's work together to achieve more than we could do either one of them by themselves. And so yes, we're going through those discussions right now. I certainly don't want to, bias the discussions that are happening already. But I can tell you, you're absolutely right. When we go to the moon the first time, we want to make sure that our astronauts get out, they walk around the surface of the moon, and they do very meaningful work. Our goal is not just to do, a technology demonstration that, hey, look, we just landed on the moon and now we're going home. That is not the goal for the first mission. So we're working through it. I don't want to bias it right now, but there are certainly a lot of very, very inexpensive and easy experiments that you could expect. Experiments that deal with the solar winds, for example, experiments that deal with characterizing the lunar regolith and the water ice that is embedded in there. How do you characterize it? Is there any pure water ice? Is there is it easily accessible? So there's a lot that I think we're going to do on that first mission that is not expensive, but also very important and meaningful. And yes, when you have a human there, you can do a lot more, a lot faster. And it makes things maybe go quicker. But we can also, with the CLIPS precursor missions, we can make sure that the human is actually in the right spot to do a lot of really meaningful work when our humans go. So yeah, I think I'll leave it at that, not to prejudge kind of the experiments that we want to do.
Great. Thank you. So we have a couple of questions that are along the same lines. I'll read both of them. The first is from Deborah Domingue at PSI. How are you incorporating international participation, and how are we designing space policy with our international partners? And the second one is from Clive Neal. As part of the Apollo generation, we need to learn from history. Competition is not sustainable. How do you see the Artemis Accords evolving to generate a cooperative international environment?
Yeah, so the international piece is absolutely huge, and we did not have it in the Apollo program. And so it was, the entire cost was borne by us. So there's a lot of differences this time. I think one of the big differences is we have, come November, we will have 20 years of experience of how to engage with our international partners on the International Space Station. I say 20 years, that's how long we've actually been crewing the International Space Station. But that partnership goes long before those 20 years, going back to developing it. So back to the, in fact, early 80s. So look, we have these international partners. We have international partners that have very robust capabilities that didn't exist in the 1960s, and we have now international partners that are stepping up to the plate with budgets, which is something we didn't have in the 1960s. So I really think that's a big part of the sustainable effort. And yes, we need to, when you look at it, you got to create the architecture. The first thing is, what is it that we're going to design to go to the moon sustainably? And then we say, what nations are going to have responsibilities for which elements? And then we say, within each nation's responsibility, what commercial providers are going to be able to deliver on that capability? Some countries don't have the robust commercial capabilities that we have in this country, and so then once we establish their role, then they're going to have to figure out how they accomplish it, whether it's government or commercial. So bringing all that together is hugely important. But I think, to the point that both those questioners had, having international partners enables sustainability. Having commercial partners enables sustainability. And what NASA needs to do in all of these cases, we need to set high-level objectives. When I say high-level requirements, we look at the success of the Commercial Crew Program, for example. Everybody saw, Doug Hurley and Bob Behnken launch on a Crew Dragon to the International Space Station. Like, that was successful because NASA set the high-level requirements, but we didn't design the vehicle through the requirements process. And because of that, industry can go innovate. And if you look at what SpaceX did, they had pressurant tanks inside a liquid oxygen tank. Those pressurant tanks were composite overwrapped. NASA never would have done these things. We had a rocket with 9 engines. We had a rocket that came home and landed afterwards that we're going to now reuse. Like, these are things that if NASA were to write the requirements in depth itself, it would have resulted in a very different vehicle, a very different capsule, and it may not have been nearly as expensive, and it might not have reduced the cost as much. Now, I will tell you, there were a lot of skeptics about this, and I'm knocking on wood as I say this, because Bob and Doug are still on the International Space Station. Their mission is not yet over. And so we're taking it seriously every day. But my point is, we need innovation, and we need new ideas, and commercial partners bring new ideas, drive down costs, increase access. International partners, same thing, and share the cost, share the burden. So all of these are important. When we think about the gateway is a reusable command module. That's the way I think of it. It's a reusable command module in orbit around the moon. We don't have to throw away a command module every time we go to the moon. And of course, it's going to have scientific capabilities and communications capabilities. So all of that drives down costs. If we can use it for the next 15 years, we don't have to throw away a command module every time we go to the moon. So those are, I think, important. And of course, the gateway itself is international. I mean, the European service module, the first time we go to the moon in the Orion crew capsule, it will have a European service module. We're international on day one. When we launch Artemis 1 late next year, we're international. We've got 11 countries that are involved in the European service module. So all of these are going to be of great benefit as we move forward.
Yeah, thank you very much for that. And as you know, Administrator Bridenstine, we at Survey are also international. We have our European Lunar Symposium every year in May that's now led by Christina Gibbs and our European partners, and we have many other activities as well. And we have so benefited by that. And I know it's 1 minute past your time right now. I don't know if you have time for perhaps one more question.
Sure, we can do one more. That's good.
Okay, all right. So this is from Parks Easter, and how do you envision the future of the commercial space industry past the lunar base? Do you see it continuing to expand?
Yeah, so when we think about commercial right now, what we need to do is we need to have commercial industry. First of all, we need them to have customers that are not NASA. If NASA is the only customer, it's beneficial, but it's not as beneficial as it could be otherwise. So what happens on the surface of the moon is really important. Is there a market for the life support capabilities that we get from the water ice? Is there a market for maybe even taking that water ice, cracking it into hydrogen and oxygen, putting it into cryogenic form, and putting it in orbit around the moon? Could there be a market for that? I think obviously the only market right now for that would be NASA, and we really haven't even established that as our goal officially. But I'll tell you where, if there are large deposits of platinum group metals found on the surface of the moon, which I think there is a probability of. I mean, I don't know, neither does anybody else. But if we look at all of the asteroids that are impacting the Earth and we think about the asteroids that are impacting the moon, they're pretty much the same. And of course, the Earth eats them up. And the moon, again, doesn't have an active geology, doesn't have an active atmosphere. And so there could be large deposits of platinum group metals or other precious metals on the moon. And if those get discovered, I think it will fundamentally shift the race. It will have a space race. It won't be geopolitical in nature. It'll be economic in nature. And of course, the United States of America as a nation, we're not going to go to the moon to collect resources like that. Our government isn't going to do it, but our private sector will. What will, I think, happen is that our private sector will be competing against China. Our private sector will be competing against maybe Russia. So I don't see a day where our government goes after those resources, because we never have. But we certainly want to make it possible for our private sector to use those resources. And Congress has passed a bill. I was there when we did it. And it was signed by President Obama that said that if you extract resources from the surface of the moon and you apply your effort and your labor and your sweat and your equity, your money, you can have the resources of that material. Even though according to the Outer Space Treaty, which we fully agree with, you cannot appropriate the moon for national sovereignty, it is possible that you could extract the resources and own the rights to those resources. Just like in international waters, you don't own the rights to the waters, but if you extract resources, whether it be tuna or energy, you can have the rights to those resources because you're applying your equity and your effort to achieve that. So if we can create that, if we can take the international regime that we see over international waters and apply it to the surface of the moon as an international regime, the same, I think, and then platinum group metals do get discovered, I think it will change the game as far as the amount of resources going into these activities. And so I think that should be a part of what NASA is looking to discover when we go back to the moon. And if that discovery is made, I think it will change the game. I don't think NASA needs to be extracting resources, although I think about it, that could really help our budget. But that's not my goal. That's not the goal of the U.S. government. That's the job of the commercial companies should they choose to go into that industry. So I think these are important. It's what the Artemis Accords are all about. You're probably familiar with the Artemis Accords, but when all these countries want to be with us on the moon, and all these countries want to go to the moon and have presence there, we need to figure out, number one, if you're not complying with, say, the liability convention, or if you're not complying with the registration convention for activities in space, then you shouldn't be participating with us on the moon. Like, the very basic principles are, you have to adhere to the Outer Space Treaty. You have to adhere to the conventions that have come from the Outer Space Treaty. And then we look at the other international areas. You know, the Outer Space Treaty talks about operating due regard on the surface of the moon. Well, what does that mean? Due regard is the same principle as a Navy pilot that I flew with over the international waters, international airspace. If I get challenged, I say I'm a sovereign U.S. aircraft operating due regard over in international airspace. And it means you stay away from me, I'll stay away from you. We just don't interfere with each other. We need to establish that kind of dynamic on the surface of the moon, where there is a not to interfere kind of legal regime that is agreed to internationally, if not in writing, then by convention or by establishing norms of behavior. And so that's really what we tried to start with the Artemis Accords, because every country wants to be with us when we go to the moon. Okay, if you're going to be with us, there's very basic norms of behavior, starting with, you know, adhering to the Outer Space Treaty, and then following up with the conventions that come from the Outer Space Treaty, the Liability Convention, the Registration Convention, and the philosophy of operating due regard, which is on a not to interfere basis. And if we can have the countries that want to go to the moon operate under that legal regime, and then a discovery gets made, I think it will fundamentally change. It'll create the certainty necessary for the private sector to capitalize and continue this dawn of a new era in spaceflight.
Wow. That's just fantastic. And I can say on the international that we do have a lot of international participants in this meeting, and I know that they have been happy to hear you say that. We're going to be hearing from one of our survey partners tomorrow. And so that's just a fantastic way to end this. I appreciate you staying a few extra minutes, and I wish we could share some applause. It would be deafening. So we really, really appreciate this, Administrator Bridenstine, you taking your time. And please know that you have a whole community here at your disposal. We're working closely with NASA headquarters to enable some exciting science and discoveries, and I can't wait.
Awesome.
So,
well, we're very grateful for Survey. You guys have done amazing work for many years, and keep it up. And thank you for hosting this.
Thank you. All right. Thanks for your time. Thanks so much.
You bet.
Okay. Bye-bye.
Bye-bye.
Okay. So, wow, that was just fantastic, everyone.